welcome to Srividya Academy, the go-to channel for special education in KCET, JEE and NCERT mathematics. I am thrilled to have you here. If you find my videos helpful, please hit the like button and subscribe to my channel. By subscribing, you will stay updated with my latest content designed to empower students like you. Join me on this incredible journey of growth and success. Remember, your learning journey begins here. Don't forget to share this video with your friends, classmates, and anyone who can benefit from specialized math tutorials. Together, we can create an inclusive learning community where everyone thrives. Solve dy by dx plus y is equal to cos x minus sin x. The given differential equation is dy by dx plus y is equal to cos x minus sin x. Clearly, this is a linear differential equation of the form dy by dx plus py is equal to q, where p is 1 here, that is coefficient of y here, and q is cos x minus sin x. Note that p and q are functions of x. Here, integrating factor is e to the power of integral p dx. We know that while solving the linear differential equation, we have to find the integrating factor first. Integrating factor is e to the power of integral p dx. So we can remember this formula. Here p is 1. Therefore, integrating factor is equal to e to the power of integral 1 dx. That is, integral 1 dx is x. Therefore, integrating factor is e to the power of x. The solution of the linear differential equation is given by y into integrating factor is equal to integral of q into integrating factor plus c. So let us use this formula. Here in the given problem, p is 1 and q is cos x minus sin x. Therefore, the solution is y into integrating factor, that is y into e to the power of x, is equal to integral of q is cos x minus sin x here, into integrating factor is e to the power of x plus c. That is, we are supposed to integrate e to the power of x into cos x minus sin x plus c. So we get y into e to the power of x is equal to integral of e to the power of x into cos x dx minus integral of e to the power of x into sin x dx plus c. That is, we are multiplying by e to the power of x and we are integrating term by term. That is, integral e to the power of cos x minus integral e to the power of x sin x. Now let us consider this cos x as first function and e to the power of x as second function. That is, we are integrating this first integral using integration by parts. So we get y into e to the power of x is equal to first function cos x and integral of e to the power of x is e to the power of x here minus integral of e to the power of x, that is integral of e to the power of x into derivative of cos x is minus sin x, minus, let us keep this integral of e to the power of x into sin x as it is. Here I have minus into minus plus, and I have plus integral of e to the power of sin x dx minus e to the power of sin x dx, which is eliminated. Therefore, we have y into e to the power of x is equal to cos x into e to the power of x plus c, which is the required solution of the given differential equation. I hope you found this video from Srividya Academy both educational and enjoyable. If you did, please take a moment to show your support by hitting the like button and subscribing to my channel. Your engagement helps us to create more content and reach a wider audience. Thank you for being a part of this journey, and I look forward to sharing more exciting mathematical explorations with you in the future. Thank you. Wish you all the best.